Hi everyone. Here is the first video for the review sheet on logs. We're going to go through hopefully about 6 problems on here. The first page of that review sheet, hopefully we can get through all the problems that are on there. So let's go ahead and look at this first problem. The first one on here says find x to the nearest tenth. So we're solving for x here. And the way this is written, we have 9 is the base. Log base 9 of 2 is equal to 3x plus 1. So if I were to write that in exponential form, it would be 9 to the 3x plus 1 is equal to 2, right? If I took that out of log form, I'd have 9 to the 3x plus 1 is equal to 2. And that doesn't really help us there because I don't have a common base here. There's no way to get a common base, so I can't really solve for x that way. So what I would probably do then is to take the log of both sides to go ahead and solve for x. So what we would do then is log both sides, which would give you the log of 9 to the 3x plus 1 is equal to the log of 2. And then I can go ahead and use my power rule. My power rule says I can take that whole thing and bring it out in front. So I would have 3x plus 1 times the log of 9 is equal to the log of 2. 3x plus 1 would then be equal to the log of 2 divided by the log of 9. Okay, I would go ahead then and do that in my calculator. Let me quit out of here. And if I do that, I have the log of 2, close your parentheses, divided by the log of 9, close your parentheses, gives you this decimal, right? So from there then, and let me just show you, 3x plus 1 equals this, whatever this number was, it was some decimal, right? From there then, I would subtract 1 from both sides and then divide by 3. So I'd end up with x is equal to this decimal minus 1 divided by 3. Okay, so if I were to finish that up on the calculator, I would have that decimal. So I would say second answer, that pulls up my last answer. Second negative sign pulls up that previous answer, minus 1, and then divide by 3. And so that would give me my final answer. To the nearest tenth, that would be x is equal to negative 0.2. Okay, so that's how I would go ahead and solve that problem. If you were to do it as a change of base problem, you could do that as well. You get the same result. That's basically just skipping these 2 steps and getting you right to this step here. Okay, just another way to start out, but you get the same results. In problem number 2, we are going to substitute 8 in for x. So I end up with 8 to the negative 1 times 3 times 8 to the 1/3 power plus 8 to the 0 power. Okay, so 8 to the negative 1 is the same as 1 over 8. Remember, a negative exponent just moves something from the numerator to the denominator. A fractional exponent means you're taking the root. So 8 to the 1/3 power is the cube root of 8, which is just 2. So 3 times 2 would give you 6. 8 to the 0 power is 1. So I end up with 7/8 as my answer. It looks trickier than it really is. The idea here is understanding what's happening with each of these exponents. Okay, that's all that's really going on in that problem. In problem number 3, we are basically using our properties or our laws of exponents to write this as a single log. So the first thing I want to do is look at this 2, and I want to undo that power rule. When there's a number in front of the log, that means the power rule was applied. So that's the same as saying the log of a squared minus the log of b. And that subtraction sign is the quotient rule. So if I undo that, then I end up with the log of a squared over b. And that would be choice 4 there. Okay. Moving on, let's look at problem number 4. In problem number 4, it says the expression log times the square root of 7 cubed. I'm just going to do that over here. That's the same as saying the log of 7 cubed raised to the 1/2 power. Okay? Remember, the square root is the same as raising something to the 1/2 power. And so I can go ahead and apply my power rule. If I want to, I can do that here. Or when you are raising an exponent to a power, you can multiply those together. So this is really the same as the log of 7 to the 3/2 power. And now you can go ahead and apply your power rule. Bring that whole exponent out in front. So that would be 3/2 log 7. Okay? All of this stuff is just knowing the little intricacies and the rules of logs. That's what's really important here. Okay, in number 5, it says find x to the nearest thousandth. Okay, so the first thing I want to do is kind of isolate my term over here. I end up with 1/2 e to the negative 4 plus x is equal to 2. If I subtract 3 from both sides. And then if I multiply both sides, right, by 2 to get rid of the 1/2, I end up with e to the negative 4 plus x is equal to 4. From here then, if I take the log of both sides, because it's base e, I can just do ln, right, because that's a natural log. So ln of e to the negative 4 plus x would equal the ln of 4. And remember, on this side, this is one of our properties, right? Log base e of e to this power is just the power. So I end up with negative 4 plus x is equal to ln of 4. So x is going to equal ln of 4 plus 4. That you can do right in your calculator. Saying ln of 4, make sure you close your parentheses, otherwise you're going to get the wrong answer. Plus 4, and that would give you to the nearest thousandth, that's 3 decimal places, so 5.386. 5.386. And the last problem on here, solving the log equation. Remember, what I want to do ideally is to get this side of my equation in terms of a single log. And there actually is a typo here. You can't do ln of base 8. That doesn't even make sense. This should say log here, and this should say log here. There's a typo on that sheet. Okay, so what I'm going to do is I'm going to undo my product rule here. The plus means I had the product rule. So this is the same as saying the log base 8 of x minus 6 times x plus 6 is equal to 2. And so now, because I only have log on one side, I want to take it out of log form and put it into exponential form. So 8 squared is 64. So 64 is equal to x minus 6 times x plus 6. If I were to multiply those together, that gives me x squared minus 36 is 64, which is the same as saying x squared minus 100 is equal to 0. X minus 10, x plus 10. So you get x equals 10 and x equals negative 10 as your two solutions. Remember we said that it's fine if here you get a negative. It's once you plug it into the original problem, if you end up with a negative, then you have to exclude that from your solution. Okay, so the fact that x equals negative 10 here doesn't matter. However, when I plug negative 10 in here, it makes both of them negative, but it only needs to make one of them negative to reject it as a solution. And 10 actually works, it keeps both of these positive, so my only solution to that problem is x equals 10. So those are the first 6 problems on that review sheet. Tomorrow I'll have a video for you on the solutions for the next part of that review sheet. Thanks everybody. Take care. Have a good day.